All right. Well, welcome back. We are Thursday. This week seems like it's going by quick. Um, Periods are super short, so it doesn't seem like we get quite as much done during each period. So I kind of figured that we'd finish all of that yesterday, but it's going to take us yesterday and today to finish off. Hadn't really accounted for just how short the periods are. So anyways, we're going to get started on it. Just a quick reminder, make sure you're taking roll every day. And remember, if you do need to talk to a counselor, that there's always one. If you just click the last selection on your roll sheet each day, it'll connect you with a counselor. They'll get in touch with you soon. Okay. All righty. So again, we just started doing our electrical yesterday, so that's the very first stuff we were getting into. And I do want to remind everyone that, let me make this huge and then I'll share my screen. So I do want to remind everyone that, okay, sorry about that. Let me just get this going, then I can focus. Okay, so I do want to remind everyone, we're covering some of this safety stuff here, and a lot of this is grisly, it's gruesome, but I think it's very important as professionals that you understand just exactly what we're dealing with here. Okay, so I trust that all of you will be serious and take this with the gravity that it's being shown. These are people, and and you're going to see some cases where they lost their life. So let's be respectful of these people. Now, in all truthfulness, they did something really stupid. But again, this is somebody's life. This is somebody's kid. This is possibly somebody's friend or father, child. We don't, it's going to be some of those things to people. So we want to treat it with the gravity it deserves. It is pretty gruesome, but I did want to bring home just what kind of dangers we're dealing with electricity. Now in this class, it's pretty rare that we go through a whole year without somebody getting shocked. Almost always somebody does. And usually when we get to the robotics and we start doing all the electronics wiring, we'll usually have somebody wire up something stupid and smoke it or burn themselves on something. But in general, we don't usually use super high voltages. So the chance for us to be killed with electricity is practically zero. I can't say it's zero because you could always do something really dumb, but in general, as long as you're following along, the chances of that are pretty much zero. But we do usually have somebody or a couple people get shocked. They'll touch something in the wrong spot, or they'll wire things across where they shouldn't. And that's all common with electricity, okay? That's part of the learning process. And even to this day, I still screw things up every once in a while. And I'm like, you moron, why did you do that? You should know better. But even still, some of this stuff gets complicated, and you'll put wires where they shouldn't go. And, sometimes one of the things I like to tell people is cars in the 90s had 7 miles of wiring in them. 7 miles of wire. Okay, there's a lot of wire. There's hundreds of different colors of wires. And a lot of times when you're doing really complicated wiring diagrams, you're going to get confused and you're going to put something in the wrong spot. And you just hope that it's not going to burn something important up like the car's computer or something very expensive. So shocking is a possibility, but this is the extreme of being shocked, okay? So what I'm showing you here is the high end of voltages and electricity, okay? We're not dealing with this kind of gravity of electricity, but I think it's so important to understand the dangers involved. And you always want to look at worst case scenarios, because that'll shock your brain and make you say to yourself, yeah, I got to be careful when I'm working with this stuff. We are going to see some really kind of scary small numbers that can still damage you. So I do want to point it out. While we're not working with these massive voltages and amperages that you're going to see here, it doesn't take all of this to do some damage, especially if you have a weak heart, okay? And sometimes we don't know that we have a weak heart until something happens. Okay, let's go through this. So we also learned too that we had voltages that when you touch them, they will shock you so much that they'll throw you back, okay? And then we also learned that there's voltages that you grab and they'll start damaging you, but they clench your muscles and you will not let go, okay? So the two voltages in the house that we have are 120 volts and 240 volts. And when you grab a 240 volt, it's enough voltage that usually it throws you back. So you touch it and bang, it throws you back. But if you touch a 110 or 120 volt, you touch it and sometimes it clenches your muscles tight on it. I told you my story of how that happened to me once. It's only happened to me once, and I've been shocked probably 20 to 50 times over my life with just alternating current voltage, okay? I've worked with electricity for a long time, and you get shocked every once in a while. So I've touched it, like I said, I've probably been shocked, I don't know, 20 to 50 times, somewhere in there, probably closer to the 20 side, but I have never had it make me clench down except for that one time. Usually it shocks you and you pull your hands away. Yeah, Mason?
Can you hear me okay?
Yes.
Okay, so you know I was talking about like PS3 controller charger yesterday?
Yes.
Now it has the chew marks all over it. I can actually show you it. So you can see like, I don't know if it'll show up on the camera, it's like it'll shoot up on the end. Like right where the part you stick in the controller is. But yeah,
I can't.
would that electrocute me?
No, it's hard to tell looking at that. Is that a USB
That's
plug?
USB.
It is a USB. So USBs are typically going to be 5.5 volts. So they're pretty small, the amount of electricity going through there. So it could shock you, but the risk is of doing anything damaging to you is very, very low. So yeah, it's not going to cause a death or something like that. It's very, very low risk of any of that kind of stuff happening. You know, maybe if someone had a pacemaker or something, but you can always wrap electrical tape around a cord that's been slit or severed a little bit, or it's starting to fray. You can always put electrical tape around it just to keep it from having any stray sparks come out or stray voltages. Okay, so we found those two different voltage. Again, the 110, even though it's less voltage, it could be more dangerous because it makes you clamp down. So just something to think about, okay? Now, however, the potential seriousness of the shock depends on the pathway through the body that the current takes. Remember, the most dangerous parts of your body are what?
The heart and the brain.
Beautiful, heart and the brain. Okay, those are the two that you don't want the electricity to go through. And surprisingly enough, it's actually your heart that's the most threatened by electricity, because just one little beat off and your heart can collapse. And if it collapses, sometimes it doesn't pop right back open. So sometimes it kind of like sticks to itself and it won't reopen, and then your heart's not pumping. So it's actually the most dangerous is to your heart, which is surprising because you would think your brain is more delicate, but in this case, your heart's the most delicate. Okay, and then if you get enough shock to where it causes death, that's what's called electrocution. Let's see, is it playing? There we go. Okay, let me move this thing out of the way here so I can actually read. Okay, if the voltage is less than 200 volts, then the human skin, more precisely called stratum corneum, is the main contributor to the impedance of the body in the case of a macro shock. In other words, your skin is the resistance to that electricity getting inside of your body, okay? The passing of current between two contact points on the skin. The characteristics of the skin are nonlinear, however. If the voltage is above 450 to 600 volts, then dielectric breakdown of the skin occurs. Okay, now, that's confusing, but let me get to the next little bit here. Okay, the protection offered by the skin is lowered by perspiration, and this is accelerated if the electricity causes muscles to contract above the let go threshold for a sustained period of time. Okay, in other words, your skin is actually a pretty good resistor, okay? And it's gonna protect you from getting shocked somewhat, okay? But the higher the voltage, the more likely it is that the voltage will go right through your skin. So sometimes if it's a small amount of volts, your skin will be enough of an insulator to protect you, okay? However, anytime the skin is wet, anytime the skin is dirty, or if you start to perspire, that's even worse because that's salt water, and that's going to be more conductive to electricity. So all of these things make it more likely that you're going to get shocked, okay? So anyways, let's just go with that. All right, here we go. Okay. All right, and then we already talked about this. If the circuit is established inside of your body, the lethality is going to be much higher. So it has a much likelier chance of killing you if the pathway goes through the heart. So you've probably all heard that electricity follows the path of least resistance. And if you were in class right now, I would be showing you on one of our boards. I have this cool little Lichtenberg burner where you put two probes on a board and the electricity connects and it burns the board. In fact, maybe I'll do a demonstration on camera on that Monday. If you guys remind me, I'll do that. It's really cool. And it's going to follow the path of least resistance through the board. And sometimes you would think that's a straight line, but it isn't usually. It usually is going to go the path with the least electrical resistance, which is not necessarily a straight line. So remind me Monday, I'll do that Lichtenberg burner just demonstration, okay? But if that path goes through your heart, that's when you're going to get damaged. I don't know if you've ever seen it, but a lot of times in old days, the electricians would work with their right hand and they put their left hand over their body and they would keep their left side turned away, and they would work with their right hand on the electrical panel, hoping that if the electricity hit them, it would go through their right side of their body down to their feet. And since your heart's on the left side, it would be avoided. So that's kind of the path there, okay? Currents of only 10 milliamps can be sufficient to cause fibrillation in this case, so stopping of your heart. Okay, 10 milliamps, that's 10 thousandths of an amp. That's very, very small amount, okay? Okay, so let's get through that. Okay, now, one of the things that people don't understand a lot is when you get shocked, it's not just about the shock that you get, it's actually also about the burns. Oops, hold on. Let me just get this one slide first. Oops. Okay. Yeah, somebody put about the 9-volt battery to the tongue. Yeah, I got tricked into that as a kid too, when it shocks you. That's a good example. Oh, this thing keeps going ahead. Okay, we're just about to get into seeing what happens here. So the other thing you need to worry about with electricity, and this can actually be even worse, is this, is when you have resistance, you also have heat. And with electricity, you get really fast, instant heat, like unbelievably fast. I don't know if any of you have heard about welding, but welding uses an electric arc and it instantly turns metal into a molten steel, okay? That could be 2,300 degrees that it does in a fraction of a second, okay? Electricity has tremendous energy in it, and it can heat things up really quick. If you remember, your skin is a resistor, and lots of parts of your body are resistors too. So when you introduce electricity into a resistor, the resistor heats up. That's how it resists the electricity. It heats up quite a bit. And so electrical burns are one of the biggest problems with electricity, is because it actually is cooking you from the inside. When you're getting shocked, it's actually cooking you. So voltage levels of 500 to 1,000 volts tend to cause internal burns due to the large energy available from the source, okay? So that it's like it's cooking your organs from inside, okay? It is a relatively unknown fact that more electrical workers die from burns than from an electric shock. In fact, only around 20% of the deaths are the result of electric shock. Okay, so now we're going to be looking at some people here. Okay, now like I said, I want to treat this with the respect that it deserves, because these were people here, and they're no longer with us because they did something really stupid. But so what you're looking at here is copper thieves. They're trying to pull the wires off of the main electrical poles. Okay, those huge wires that you see up there. They're fat. They're probably like an inch and a quarter wide. They're big wires. Okay, so there's a lot of copper in there, and they want to recycle that copper to, you know, make a few bucks to score some drugs or something. Okay, so you can see there's a bolt cutter here, which is a really stupid tool to use because it's not electrically insulated very well. You notice it's got some rubber handles, but they're barely big enough for your hands, so more than likely your hands are going to touch the metal anyways. And the amount of voltage we're talking about running through power lines, 12 to 13,000 volts. Yeah, see in this one, 13,200 volts. Okay, that's a huge amount of electricity running through those power lines. Okay, and if two of those things touch, you're in big trouble. Okay, like this kind of trouble. So you can see they reached up there, started trying to cut the wires or touched across two wires. Now, if they touched one wire, they would be fine. Okay, that you'll see that with birds all the time. Birds land on these electrical wires all the time. There's no insulation on the wires. The birds land on them. 12,000 volts is flowing through that electrical line, and the birds are fine. Okay, but every once in a while, a bird's wing touches the second one as it goes to take off, and it's going to instantly kill that bird because you're touching two. We'll learn about this when we do safety, but you can see this guy, he's totally burned up. And this probably happened in a fraction of 1 second, meaning he touched the wrong things and bang, smoked it quick. Okay, you can see him there. I'm going to play this. You got to speak up a little.
What is
What
that
if you're
next
touching
to
the
him?
ground?
It sounded like there was some question, guys, but I could barely hear him.
What is that next to him?
What do you mean, the black, like, snake-looking thing?
Yeah.
That's the electrical line.
Oh, okay.
Sule was asking if, like, what would happen if you touched the ground while that was happening. Like, your ground.
Sorry, Michael, you kind of cut out a little bit at the end there. What would happen if you touched what?
What would happen if you touched the ground while you were touching the wire?
Okay, so we'll talk about that, but that's a good call. If you were tall enough to be able to reach the wire and the ground at the same time, you would be shocked, probably electrocuted. Like, it would kill you probably. So you can't touch two wires together, and you can't touch one wire and the ground together. So either one of those will kill you. It's a good question, and that shows a lot of insight. We're going to talk about that when we talk about how do you avoid getting shocked. But the first day, I just like to show you what the effects are. Okay, so it's hard to see, but now you can see it from a better angle. Okay, notice there's two people here, actually. I'm going to back up a little bit. You couldn't even see the guy because everything's so burnt, and it just instantly fried. But you can see there's a second person here, okay? So I said, very frightening, very scary types of events. You see this a lot in poorer countries where I'll show you later, but some of the power setups in the other countries are horrendous. They're not safe at all, especially India and Russia have some just god-awful electrical setups that they have running out there. I'll show you some pictures of them, and you would just be scared to death to work on any electrical in those countries. And so you see this a lot in poorer countries when a storm comes through and knocks the power lines down, and then people are subjected to those wires as they fall down. So there's some really tragic ones on YouTube if you go and search. But electrical is nothing to mess around with, okay? Nothing to mess around with. Let's see here. So then under dry conditions, the resistance offered by the human body may be as high as 100,000 ohms, okay? Now, if we were in class right now, I would actually have a few people checking with a multimeter and see what our resistances were, but
Isn't that bad if you have a high resistance because you'll burn?
No, it doesn't mean it's bad. Usually people that eat more salt have less resistance, and people that eat more salt have less resistance. People that eat less salt have more resistance. But it's not perfect. I've seen people go from about 1 to 3 million ohms, so it changes quite a bit.
I'm saying, wouldn't you burn more if you had a
Higher resistance, yes.
Okay.
Yeah, but the differences between humans is not so much like one person's not going to burn up. Everyone's going to burn up. Okay, and then here, wet or broken skin may drop the body's resistance to 1,000 ohms. Okay. All right, let's see. Is there anything else I wanted to cover in this one? I kind of think that's, we're going to get the rest of the stuff in the next slide when we talk about the safety. Okay, so let me stop sharing this one here. I will close that one out. Okay. How much time we got? Just a few minutes. Okay, I'm going to save the other one, I think, till tomorrow. The other one's really exciting because it's an arc flash and you see an explosion. That's one of the other dangers with electricity. So we'll do that one tomorrow. It's only a short video, but we're running out of time today. So if anyone has any questions, feel free to ask. I'd also like to remind you that I graded your process journals. And if you need to make anything up, there's a lot of zeros out there. And it's kind of depressing, actually, because as an advanced class, you guys should not be having zeros on any assignment. That's kind of ridiculous, especially when I've given you a lot of time to make them up. But if you do want to make up any of your assignments that you missed, I will take late work. However, you must turn it in at the end of class. So like all these days when I give you a few minutes at the end and I say, okay, anyone have questions? That's when you need to turn it in to me. You need to say, Mr. A, I redid something. Here's what I redid. Can you grade it for me? And I'll grade it for you at the end of class there. Okay. Otherwise, it just gets too confusing with emails back and forth. So
how do we check our grades?
What's that?
How do we check our grades?
That's a good question, and I have no idea. They sent some videos out to your parents, but I don't know how to do it. Maybe one of these other students does.
Yeah, you check the